Despite working at a couple of major tech companies, Stephen has never actually been the one to tap release on the button to release an app to the App Store. So,
thank you.
Yeah.
In many ways, I'm actually further behind almost anyone here in this room in terms of Swift development. At Twitter, where I was for 3 years, I worked on the TwitterKit SDK, and we had to use Objective-C. And Yammer before that, before Microsoft bought them, we didn't use Swift except for a couple of unit tests. So this is me. I'm from the middle of Canada, where it gets chilly sometimes in the winter. Before I was an iOS engineer, I worked on software at BlackBerry for a little bit. Inside the box are some secret new BlackBerry devices. My team would run tests on them, and we had to verify that emergency calls would work properly, and they needed to be tested inside a room that had metal walls and ceilings and doors to make sure that there weren't any real calls being made anytime. So it's kind of appropriate that at Airbnb right now, I'm working on a team that helps to make testing really efficient, and we try and make builds faster, and we try and improve the developer experience for the engineers. And when I say me, I mean my partner, who supports 40 Android engineers, and I, who support 40 iOS engineers. I'm actually not much of an indie developer. As you know, I never hit release on an app in the App Store. And one of the apps I did work at the first place after I quit my job to learn mobile development. We built an app for the government in Canada, and you couldn't see real customer data until you made a pledge to the Queen. And so there was a couple of bugs that they had said, hey, Stephen, can you work on it? And I said, well, I actually haven't taken the pledge yet, so sorry, maybe you'll have to find someone else to do it. Now, I'd like you to imagine a world where you can edit the configuration of your app in a very modular way. I'd like you to imagine a world where you can add new files to your project or to a module just by creating them in the proper directory on your file system. And I'd like you to imagine that you can lint that configuration, or you can run tests on that configuration and make sure that someone on your team hasn't made any inadvertent changes. I'd like you to imagine not needing to use Xcode directly. Now, I know all of us love Xcode, and there's never any problems with it. I mean, it is a very pretty editor, and the debugger is pretty nice when it's working well. And it has some nice memory inspector features, and it's added a little bit of view debugging. But sometimes it's nice to use your text editor of choice with whatever plugins it is that you love. Sometimes it's nice to be able to build up a command line alias for common actions that you take. And it's handy to be able to take your work that you do day to day and make sure that that is the exact same thing that's happening on your continuous integration infrastructure. Look at how happy this team is. They're able to work together on different parts of their app, and they don't have to worry about their project files having merge conflicts in them. They don't need to worry about taking a file from one part of their project and moving it to another part of their project and trying to parse which hash has changed and what its parent group inside the legacy PBX proj format is. I would like to introduce the Buck build system. This isn't something new. It's been around for at least 3 years. And it wasn't even open sourced right away. And I'll tell you the story. There was a few engineers who left Google, and they went to a small social networking startup company called Facebook. And they decided, hey, I really miss the build system that we had Google. That build system is called Blaze internally. They said, I like how we can edit configuration files and it can be the same build system for Java and C++ and our mobile apps. And they asked their old managers, hey, will you open source Blaze? And Google said, nope. And they said, no problem. I remember mostly how it worked. I can build my own thing. And so they built Buck, and they made the build files look very similar. And a couple of years later, Google said, hey, maybe that was not a great idea. Maybe it would be smart for us to open source our build system. And so they kept all the same letters and they called it Bazel. So if you read about these online, you can see that a lot of the largest mobile companies are already using or migrating to use these build systems for a variety of reasons. In particular, they'll do it for deterministic builds, for excellent caching, especially if it's over the network, and for being able to work in a larger team. This is one of the biggest factors for moving to a build system like this. If you only have a few engineers, maybe it's not worth the learning curve or the extra work that's required to migrate. But once you get to be more than 10 or 20 engineers, especially when you hit 40 or more, you see we need to be able to grow in a way that's not limited by a single file for a project, or in a way that's limited by the way that our caching system is set up on each engineer's laptop. So when you hear the words Buck, you know, hey, that is a build system. And mostly we know that this is what Facebook uses to build their mobile apps, but you don't necessarily get an idea of what else it is, what's inside it. It turns out that it's actually more than that. There's a build system, there's also a project generator, and there's an excellent caching system, which is the key to why it is so fast. And so I'm going to talk about these, but first I'll explain what a Buck file even looks like and why it allows you to do the things that you can do. You can see here a simple file. It looks a lot like Python. That's because it's exactly what it started out as. And each of these functions are actually explaining how to build a single piece of your app. In this case, it's a library that has some sources and dependencies. It has a certain name. And there's a number of other pieces of information you can add to one of these Buck rules. In this case, we can also specify the way imports should be handled, whether it's modular or not, and whether it should be visible to just this file or other parts of it. And one of the key pieces is this top section, that it can have load commands for common Buck rules or Buck macros, and you get a really clear idea where each piece of logic is coming from. Rule macros are handy ways to have a shortcut that you don't need to specify every part of a single rule, that you can say, hey, it would be handy if every pod dependency doesn't need to worry about warnings, but all of my own libraries, I would like to make sure that those warnings are treated as errors. Or all of my tests, I would like to make sure that they're using a default version of Swift. These pieces in a Buck file allow you to specify what the thing is as well. That you can have an Apple library, an Apple test, those would be most common ones, but also an Apple binary or an Apple package. And these allow you to make a number of smaller apps inside your repository, and those are really handy as your project gets bigger, so that you can have teams that only work on their little app instead of having to build the whole thing every time. You can also share your settings. You may already be using xcconfig files, and those are an excellent way to put settings in a single place. They let you add comments to your settings and have reasoning on why you set things a certain way. This is super common in bigger companies where you need specific settings for certain modules. And these configs can use logic, any type of logic that you would do in Python. And so you can add up build settings. You can have default values or even string interpolation in here, which is super handy, and it allows you to reduce the duplication that you may have had in your Xcode build settings. Now, if this is something you try out and you want to change your files, this buck audit command will look at a build rule and it will fill in all of the glob values, all of the configuration, and you can either lint this output, or you can have tests on this output, or you can just do it in your regular day-to-day. It's not something that engineers need to know, but is really handy for being able to confirm that your app is building exactly the way that you wanted it to. This team is so excited to be modifying settings directly in their favorite text editor. All right, here's the buck build system. This is what it'll look like when you run a command, when you run a build. You can see exactly how long it took to build. I have a bash edition that will show how long it took to build. In this case, it's too light, and you can see the first build took 30 seconds, and doing another build is only 3 seconds. So that cache is able to speed it up quite a bit. The build system actually just looks at your buck files, and it will pass your source files to the exact same Clang compiler that Xcode was using, the exact same Swift-C compiler that Xcode was using, and even internals like AC-Tool and IB-Tool for asset catalogs or interface builder files. And you can actually investigate what Xcode was doing in any type of build. This is the view that you're more used to seeing. You can see each step, and if you expand it, you can actually see what the compiler was and what every argument was to it. And this is using PSTree, just being able to see, hey, these are the exact Clang commands or Swift commands that are being run. And this is actually what SpaceX did when they migrated to Bazel, because they wanted to make sure that every invocation of the Swift compiler was using all of the same arguments to their C and C++ project. Project generation. This is something that most new iOS engineers never really think about, or they think that it's a really niche edge case, that I can use Xcode fine, I understand everything about how it works, but once your team grows to be larger, it makes sense to use a common format to be able to specify what modules should look like, or make it easier to add a new module or split up your app into pieces. All of those companies on that list are already generating their Xcode projects and generally not even checking them into their project. And this means that you only have one source of truth. The source of truth is a file that you can see, and the only additional work that you need to do is to generate those project files if you're going to be using Xcode directly as your editor. And it turns out that a lot of engineers will do that, even at larger companies like Uber and Facebook, where you can build right from your text editor and use the command line. The majority of mobile engineers are still used to Xcode. It's nice to be able to click in the gutter and add a breakpoint and to see what's going to happen. Apple does improve Xcode every year, and they add great options for incremental compilation of Swift. and things like that. And so generating an Xcode project is still handy for the majority of engineers and is not something that you want to force on your team just because you're wanting to use a different build system. One interesting note between Bazel and Buck is that Bazel project generation can actually give you two options for building, that you can still use Xcode build under the hood, or you can use a Bazel build, and it can even try and change Xcode's the progress meter. And some companies, I won't mention which ones they are, will decide to unsign Xcode for local engineers. You'd never do it for a CI build. You'd never do it for a machine that builds for your app store, but it allows you to have a better or a different experience when you're using Xcode locally, and you can do things like improve that progress bar or have different types of plugins. If you've ever looked inside your Xcode project, this is actually what it looks like. You can see that every file is listed. There's a hash here. If you put them inside groups, they're in various places. This is not super easy to view and to change yourself. And you can imagine what the diff looks like if you move a file from one place to another. I know most engineers will just say, it looks good, I hope it's fine, and make sure that their CI build will still run. But for a project like Buck, you can just add a new file to your project directory and, and if it matches the glob, it will magically end up in your project. That this will look for anything under the Swift1 directory, and using the Watchman tool, that's what Facebook developed that listens to all the file system events, you don't even need to parse the directory tree each time you do a build. So I don't know if you've ever used make or cmake and have added a new file and run a build again and wondered why things weren't changing, or maybe you pulled from Git and your app doesn't seem to be different, and it's because your build system was using the file modified times and one is further ahead in the future. Since Buck uses Watchman, that isn't an issue, and it can automatically know which single file has changed out of the 1,000 or 10,000 files in your project without having to do that parse every time. The project generator looks at your Buck file and also the source files, and it creates the Xcode project that you can use day to day, and your team will generally add these to the git ignore file. They won't even be checked into the repository, and that means that you'll never have to worry about what that generated file looks like, and you'll never have to worry about a new engineer joining your team, changing a build setting inside the Xcode project instead of your xcconfig, or having to worry about what the nested settings are going to impact whether someone changed the build setting in the wrong place. So you may see, hey, Buck is a reasonable build tool. It can generate projects, but I could already do that with Xcode project, the popular Ruby gem. I could already use Xcode build directly from the command line, and Xcode already puts build artifacts inside derived data. Why do I care to go through a huge hassle about rewriting my configurations, and why would I want to use something else if I already have these tools that exist for me? And this is really the key, is having a caching system that works excellently and a caching system that takes into account all the things that you care about for the rule keys. When Facebook investigated their builds internally, they found that only 3% of each build was unique. That means that 97% of the time that engineers are spending doing compiles on their local machine are a waste. And we care about not repeating ourselves when we're writing code, so we should really care about not repeating ourselves when we're building code. But it's not something that we do. The way that Buck handles this is it looks at your Buck file, it uses Watchman to get the SHA-1 of every file, and it will calculate a rule key for each of the rules, and that will be used as the cache key when it puts it in your local cache, or even better, your network cache. Each of those rules that I showed you has a rule key associated with it. You can see here the rule and the calculated hash. And that hash is calculated with the input files, which is what you'd expect. Of course, Xcode will do this. It will also look at the flags that you're passing to the Swift compiler, to the C compiler, everything that you've specified in your Buck config. Those are part of the rule key. And so if you change them, you don't have to worry about getting an artifact from derived data that was built with different arguments, that was a stripping or not stripping debug symbols, whatever that case was. It also takes into account the compiler version. I know that as iOS engineers, we generally just accept that if I make a build with Xcode 9 and then I upgrade and I try and build again, I'm probably just going to have to delete my drive data. And for a lot of us, we just shrug our shoulders and say that's fine. But if you have a continuous integration system that's running tests, and it's running hundreds of tests, you have hundreds of machines. At Airbnb, we have a very mid-range number of machines. We have 150 Mac Minis in a couple racks, one in our office and one in a data center. But a lot of the other companies on the list, they're into thousands and thousands of Mac Minis. And some of them will allocate multiple Mac Minis per engineer because it provides enough value for their cost and it finds enough issues without forcing engineers to do the work that it is totally worth it to them. And so in a situation like that, you want to be able to have several versions of Xcode running, or you want to be able to make sure that builds don't just spike when you try a new beta of Xcode. And so being able to make sure the cache takes that into account is very important. Also, taking the build tool version into account is really useful. It means that you can have multiple versions of Buck on your computer, and those artifacts will sit side by side in the cache, and you don't have to worry about them clobbering each other. And lastly, as you could imagine, these are pure functions, and so with the same inputs, you always get the same output, and the dependencies that you have for a rule key, the SHA of those dependencies will impact this particular rule. This is something that you could reveal to developers or not. They can investigate it themselves, but it's interesting to see how they change when you change a single file. In this really simple example, there's an app binary, an Objective-C library, a Swift library, and they each have a certain hash. If you change one of those, the only things that your build system needs to rebuild are the library itself and whatever depends on it. Now, if there's people in the audience who also build Android or who build Java backend services, the compiler can actually tell whether your change that you made was the internals of a private function, or the type signature of a private function, or the name of a parameter, or the type of a parameter. If you just change a parameter name or a private function, Buck doesn't even need to compile the things that depend on it because the interface is still the same. As Swift developers, we are a little bit behind in this case, but you see discussions for Swift 5 on having a smarter Swift compiler that's able to know those exact same things about whether you've only changed internals or the public interface, and not having to recompile things that depend on it. So that is super exciting as well. In this case, you see that I've split up Objective-C in Swift, but one of the strengths of the Buck compiler is that it actually supports mixed modules right now. And that's something that Bazel doesn't support. So if you're trying out both build systems or you're thinking about it, I feel like Buck is still the very best for reasons that you can use mixed modules while you're migrating, that you can nest your caches. It can check the local disk cache first, and then the network cache, and that it can support header maps in Xcode, which Pinterest found reduced their Xcode build times by 30%. These people are just super happy changing their files again. All right, there's a couple of extra features as well that theoretically should be possible with Xcode, but we all need to file radars and ask Apple to add these as output options for our builds. Dependency graphs. This is super simple, that you can have a graph viz output of which modules depend on which other modules. And it turns out that this is really useful for a team to be able to make sure that you have the dependencies that you thought you did. Sometimes it turns out that you think everything makes sense until you generate one of these graphs, and you see that there's a lot of modules that depend on some God module, or that your top-level app module depends on more things than you'd like. And so this is something that you can actually run on your CI system every day if you want. You can upload the image to an internal website. Maybe you just want to have someone's job to check this out once a month and then bring it to your next mobile meeting to discuss how you can guide things in the direction that you wanted. Also, these build trace files I've found to be one of the most useful parts of improving your builds. You think that a build is just as fast as it is, but it turns out that if you can see the order that builds happen, it fairly quickly is able to show that you've got a bottleneck here in your app. In our case at Airbnb, we looked at these build trace files. I shared with the engineering team how you could look at them directly, and we had 4 or 5 of these bottlenecks where only a single core was being used on local developer machines and a single core was being used on our Mac Minis on CI. And each one would waste a minute of build time. And the engineers responsible for each of these modules said, that doesn't make sense. We don't actually need to be bottlenecked on that thing. We can split it up into pieces, or we can use dependency injection so that this module isn't actually directly instantiating this other one, that it just receives an object that conforms to a protocol. And you initially imagine that something like that is just handy for the way that you're designing your coding contracts. But it turns out if modules don't directly depend on each other, you can build them in parallel and you can shave minutes off your builds. And that can save you dollars, can save you engineering goodwill, it can save you power, whatever it is that you care about, it is really useful for your team. And so in our case, you can see that we have one last large bottleneck, and this would be a good thing for us to tackle. And engineers may have said, hey, I'm going to fix that thing, but if no one knows about it, it's hard to get credit for that work. And as you know, if you have some data that you can show to your manager and you said, look, this is the time that we were wasting, and I shaved a couple minutes off the build, would be a good time for a promotion. This is a perfect tool for something like that, because it allows you to quantify the improvements that you're making. And it would have been something that you could do anyways, just out of goodwill, but if you can have your professional goals aligned with what's best for the team, it is something that's super valuable for everyone. So, we've all got Xcode somewhere, and I've hopefully convinced you to at least try Buck with a small piece of your app or a small project that you're working on, or just for some sort of hack day to see how this build system works. What is it that you would do next to give it a shot? I am going to show you a pretty simple example of doing a Buck build, and I am going to use the command line for build. And so if you are a pure iOS developer, I'd like to say this might be horrifying. And if you are someone who's come from a Linux background, this might be a breath of fresh air. You can see here, this is a Buck config file. These are sample values that exist. This whole project you can see right now on github.com/airbnb/bucksample. I felt like there's so many hurdles to try a build system like this. If you get any of these settings wrong, your build may not work. And I like to say that Buck is so great because it allows you to learn about all the arguments to the compilers you use. But you can also say that Buck is so terrible because it forces you to learn about all the arguments to the compilers you can use. So this is the most simple Buck rule. Not even most simple, but it has a name, a certain glob, some dependencies. For an app, you can see, hey, I have some assets, resources, a binary. I can specify the Swift version directly or sources directly or use globs. And I can even specify what I want specifically in this workspace. Maybe this will be my top level workspace. And I want other workspaces to also be able to have smaller apps for each individual team. Being able to add additional scheme actions is actually super valuable for a team because you can add logging to the beginning and end of any Xcode build, and you can have a graph saying, hey, our build's been getting slower, or it has been getting faster, and you can talk to your manager about it. You can use Make or any other type of build system that you want. And if you zoom in, you can see this is simply the command that was run. And so in that repository, you can see that you can do a build or generate a project or whatever else it was. And if I open you can see this shows which thread is being used to build which thing. In this case, I have a single pod dependency that is taking a longer time. And when it's done, I'm going to open the output directory and show you how you can drag the build.trace file right into Chrome. In Chrome, you just need to open up about:tracing. This is all in the Buck docs, and this will allow us to see the build graph. Chrome actually has built into it a tool called Catapult, which is generally used for viewing trace files like this from other projects. It's definitely not proprietary. If I had a more reasonable resolution, you could see it. But you can actually see the bottlenecks. You can see that the asset catalog tool inside Xcode is being used to make your entitlements, look at your info plist file. And when you select any of those, you can't even see it under the bottom here. This is terrible. But you can see the arguments that are being passed to each of these compilers. So I think I'm going to leave this as exercise for the reader. You can see that builds work. You can run right to the simulator. You can run the debugger from the command line, or you can just generate a project and let people use Xcode like they always have, but with a consistent format. All right, so we heard a little bit about how you can use Buck in your day-to-day life. The resolutions are not great. My name is Stephen Hepting on Twitter, shepting on GitHub, and feel free to ask me afterwards about what you may be having as a roadblock or hindrance to trying something like this out, or just trying to say, hey, why would this work for me and my company in particular? In our case, our Buck builds were able to improve our build times from about 17 minutes to 15 minutes without any sort of cache. And then when we turned on the network cache, you could see one of the charts from earlier in the build, how the build times on our CI machines went from 15 minutes to 3.5 minutes. And so it's a big improvement, can save power, save the environment. Everyone should do it. Thanks so much for having me here.
Thank you, Stephen, for the talk. We have quite a few number of questions. So,
sure. Yeah, so the top question was, does Buck for testing also generate test coverage reports? And how does it work? So test coverage reports are something that work inside Xcode. You can use them from Xcode build from the command line. A lot of people will use different gems, whether it's Slather or something like that, right from their FAST file. So you can generate test coverage reports by passing the right arguments to Buck. I would suggest that this is definitely one of those trade-offs where it is a complicated thing to do with Buck. And so it may be that that is the thing that you do with Xcode in something like an hourly job or a daily job to show how your test coverage is working out. It is certainly something that's scheduled, and these companies do have it working, but sometimes it might take an investment of a couple weeks to figure out exactly where these settings need to be set. So that's definitely a weaker point. Are you able to use the simulator and interface builder when using Buck? It's a great question as well. In my case, I can just run make debug, or if you try the project, you can do it, and it will open the simulator up exactly the same as if you had pressed the play button in Xcode. One of the things that's more difficult is using the debugger, because you'd have to use LDB from the command line, which is fine. A lot of people are really familiar with that, but I like the experience of just being able to click in the gutter to have breakpoints. And so for my day-to-day development, I do like using Xcode for that reason. Interface Builder also works. You could see in the Buck file that there are artifacts and resources, and some of them can even be storyboard files. And so that is something that you can still edit from within Xcode if you want. And it allows you to do a migration. Maybe you don't want to jump all on board right away. You want to support both of those. In our case at Airbnb, we had our existing manually managed Xcode projects, and we modified Buck so that its projects that it generates have a -buck suffix. And so you can see both of them side by side as we do that migration. That's related to the next question. Are you able to move to Buck incrementally, or do you need to move your whole app all at once. So, like I said, in our case, we have these generated projects in parallel, side by side, with our manually managed project. And something we found that has worked really well is being able to have these smaller team-focused or module-based apps that people can build in just a minute instead of having to build the whole thing. And you can have your own interface for your team to do quick iteration. And using Buck for something like that is a good way to have a smaller rollout instead of convincing everyone to change all at once. All right, last question. What's your experience on the maintenance cost of using an alternative build system? And have our teams been blocked by the issues of it until our team fixes them? This is probably the most important question to be asking if you're going to try something like this. Because with Xcode, you can file radars. If you're a big company, you just call your contact at Apple and say, hey, this isn't working, and their engineers will try and sort it out for you. But if you use a separate build system, it means that you are responsible for making sure that build system works and making sure it works for every time Apple updates Xcode. And you could see that it's only the biggest mobile companies that have started using these tools, or mostly the biggest companies that have started using them. And I would say that's often because you want a couple people to support a system like this. And so that definitely is the case sometimes. We've often had painful migrations, or Uber and Facebook have often had painful migrations. And there's a reason that Facebook still uses Objective-C internally and doesn't use Swift. And it's for the compiler complexity and for the tooling system. And so that's definitely a case. I feel like when you hit a certain point, it is totally worth it, and that's why these companies have chosen to use it. But like everything, I think all senior engineers will say at some point that there's trade-offs for every decision, and this is definitely one of them. So I think this is a great direction for us to be going as a community. Whether you're going to do it right now is totally up to you, but I'm just happy for us to be working on this together, that people can try out the repo and submit bugs or improve it in many ways. I think it is helpful for us to nudge Apple in a direction that we want to be going. I think the very best solution would be if Apple said, hey, there's a couple awesome things about this, and we're just going to improve Xcode so you don't even need to worry about it. So let's all hope that that is the direction we go together. Thanks so much.